Hey guys, welcome back. So what we're looking at today is lesson 4 and 5. So lesson 4 is what we'll start with, dividing powers of 10. So let's go ahead and jump right in. So dividing powers of 10. Complete the table to explore patterns in the exponents when dividing powers of 10. Use the expanded column to show why the given expression is equal to the single power of 10. You may skip a single box in the table, but if you do, be prepared to explain why you skipped it. So just like we've seen before, we get to skip one of those tables, most likely because we're going to have such a large set of factors that we can't write it all out. So if we look, we've got 10 to the 4th divided by 10 to the 2nd. So we show it 4 tens over 2 tens, which is 10 over 10 and 10 over 10. Those cancel, times there's plain 10 and a plain 10. So we have 1 times 10 times 10, which gives us 10 to the 2nd for our single power. So here we have 1, 2, 3, 4, 5. So we have 10 to the 5th divided by 10 to the 2nd, because there's 2 in the denominator. We pair up the two tens that match, and then we have 3 left over. So our single power is 10 to the 3rd. Now, what do you notice is happening here? 5 minus 2 is 3. 4 minus 2 is 2. 6 minus 3 is 3. So this will be 10 to the 3rd. And the last one, 43 minus 17, which obviously is the one that we are not going to write out the expanded form for, is 10 to the 26th. So showing that expanded form for the 10 to the 6th over 10 to the 3rd, we'd have 10 times 10 times 10 times 10. See, that's 4, 5, 6, all over 10, 10, 10. I'm going to do mine a little differently. Those cancel, those cancel, those cancel. So this equals 1 times 10 times 10 times 10. So 10 to the 3rd, as we found. So which entry did we skip? Well, we skipped the 10 to the 43rd divided by 10 to the 17th because the factors were too large. Factors too large. Not enough space to write it. So use the patterns you found in the table to rewrite 10 to the n over, divided by, 10 to the m. So it'd be 10 to the n minus m. We subtract them. We will always subtract. So we take our numerator minus our denominator. So it's predicted that by 2050, there will be 10 to the 10th people living on Earth. At that time, it's predicted there will be approximately 10 to the 12th trees. How many trees will there be for each person? So we'd take 10 to the 12th and we divide it by 10 to the 10th. So this equals 10 to the 12 minus 10, which is 10 to the 2nd. So everyone would have 100 trees for themselves. So each person would have 100 trees based on that logic then. So that's what we are looking at there. So now we're going to take and jump into lesson 5, which is negative exponents with powers of 10. So still dealing with our powers of 10, but now looking at when we have negative exponents. So negative, is your key word for this lesson, negative. All right, let me get this. Oh, sorry. Didn't realize I didn't have that ready. So negative, like I said, is your keyword. All right, negative exponent table. Complete the table to explore what negative exponents mean. So using exponents, we have 10 to the 3rd, 10 to the 2nd, 10 to the 1st. So this would be just 10 to the 0, because 10 to the 0 is the same thing as 1. So 10 to the 2nd is 100. 10 to the 1st is 10. If we write it as a fraction, we'd have 1,000 over 1. We'd have 10 over 1. Now, going into the negatives, so as we go up, we've been multiplying. So as we go down, we're dividing by 10. So if we take and divide this by 10, we're going to go to the 1/10, so 0.1. Then we have our 0.01, and then this would be 0.001, 1,000, which is 1 over 1,000, or 10 to the negative third. So when we have negative exponents, it takes and converts it into a fraction. So this would be 1 over 10, and this would be 1 over 100. So anytime we have that negative fraction or negative exponent, instead of having 10 to the second, which would be 100, we do 1 over 10 to the second, which gives us 1 over 100 or 100. So as you move toward the left, each number is being multiplied by 10. What is the multiplier as you move right? So as we move to the right, it's 1/10. So we're multiplying by 1/10 or dividing by 10. How does each of these multipliers affect the placement of the decimal? So times 10 moves the decimal one place to the right, times 1/10 moves the decimal one place left. So it's just moving it one place each time, but when we're multiplying by 10, it moves it to the right, whereas by 1/10, it moves it to the left. So use patterns you found in the table to rewrite 10 to the negative 7th as a fraction. So 10 to the negative 7th would equal the same thing as 1 over 10 to the positive 7th, it's supposed to be 7, which would be 1 over 1 with 2, 3, 4, 5, 6, 7, oops, 1 too many zeros, 7 zeros. So, oops, 1, 2, 3, 4, 5, 6. I was right. I miscounted, but I accurately made zeros. So we've got, it'd be 1 over 10 million. So same thing as 1 over 10 to the 7th, because 10 to the 7th is 10 million. All right, use the patterns you found in the table to write 10 to the negative 5th as a decimal. So 10 to the negative 5th is the same thing as 1 over 10 to the positive 5th, which means we are going to have 4 zeros. So we'd have 0.1, 2, 3, 4, and 1. So there would be our decimal. So it'd be 5 places after the decimals where 1 would go. So 1, 2, 3, 4, and 5. All right, number 5, write 1 over 100 million using a single exponent. So we know it's going to be 10 to some negative exponent. We count our zeros. We've got 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 10 to the negative 8th would be our exponent for this fraction. All right, use patterns in the table to write 10 to the negative n as a fraction. So 10 to the negative n is the same thing as 1 over 10 to the positive n. So it just takes and flips it, essentially. We're doing the reciprocal of it. Instead of having 100 or 1,000, we're having 100th or 1,000. We're flipping it over and having it be fractional instead of a whole number. And this is true even when we don't have 10 as our base number. So just because all of these have been 10, it still would hold true if we're dealing with 2 or 3 or 4, any other non-10 number. Okay? All right, if you guys have any questions, feel free to ask. Also, when you're dealing with negative exponents, one last thing to add, all the other rules still apply. So if you're taking a power to another power, if one of them's negative, you're going to end up with a negative exponent. If they're both negative, then you'll end up with a positive exponent. So just be wary of that. The rules still apply. So the taking an exponent with a negative, or a base with a negative exponent times another base with a negative exponent, you'll add those exponents together. So you'll add the negative numbers together. So keep that in mind. Those old rules that we've gone through still apply when we have negative exponents. All right, if you guys have any questions, feel free to ask.